What's going on, guys? Zach Scriven here. Thanks for tuning into the channel. And today I'm super stoked because I have an awesome video planned for you guys. I'm going to be going over the PlantPAx Process Application Development Lab. So huge shout out to Rockwell for letting me do this. They're the one that sent me over this. They sent me links to their VM, so they have a virtualized environment for me to program this all in. So and I just wanted to share that with you guys. I did get permission from them. Wanted to share this with you guys to help teach you guys what PlantPAx is all about, and how you guys can use it and how to get started. So let's dive right into it. But first, I want to just give you guys a high level. So basically, PlantPAx, it's like a whole system of it's a distributed control system, and there's different parts and pieces to it. But one of the things that I like the most about it is the library of process objects, and basically that consists of add-on instructions for the Rockwell the Control Logics and Compact Logics platform, graphical templates objects for FactoryTalk View and FactoryTalk View SE and ME, and also Faceplates. So all those kind of work together in conjunction. So you basically, you could drop this on the screen, tag it with one single tag, and you have all your alarms, everything. And this is developed by Rockwell, so it's tested, it's updated, and all of this is put out for free. You just got to learn how to use it. So that's why I'm here teaching you guys how to use it. And the finished product could look something like this. So yeah, so let's get right into it. So this is the lab, and it's in a PDF format. And over here is our VM. So let me see if I can go full screen here. Okay, there we go. Okay, so I can just switch back and forth between the PDF. So let's kind of get right into it. Okay, so I'm gonna skip over this. So here's the section, so you guys can pause this and refer back to this. And I'm gonna link all the timestamps down below. So if you guys want to just jump to a specific spot, you guys can go ahead and do that. So let's talk about this. So this lab will familiarize the user with the necessary steps to start development of a PlantPAx DCS using Studio 5000 Architect and the Rockwell Automation Library of Process Objects. Okay. In this lab, it will cover the following subjects: use Studio 5000 application and templates to develop PlantPAx application, leverage process strategies for level control using a tank with a pump and level indicator as an example, configure an HMI display to include pump and level objects, test the controller program and HMI functionality by creating and using an HMI client, leverage the logical organizer to take advantage of past engineering efforts to save time and reduce errors, use program parameters to late bind IO channels to control strategies while online, and configure alarms and alarm groups. And this is what you're going to become familiar with. Tools and prerequisites: VMware Workstation v10 to run the VMware image, and I'm running this on an Azure server, so I don't need that, but you'll need Studio 5000 Architect v1, Studio 5000 Logix Designer v24 or higher, FactoryTalk View 8.1, FactoryTalk View Client 8.1, the Rockwell Automation Library of Process Objects version 3.5, and RSLogix Emulate 5000 version 24. Okay, so I'm trying to think if I want to read this. Yeah, so basically, I do think it's kind of important to touch on this before we get into it. In case you guys are interested, like I said, if you guys want to skip this and just go straight into the code, I'll put links to the timestamps below. So Rockwell Automation Library of Process Objects is a predefined library of application code, graphic objects, faceplates, and process strategies that let you quickly assemble large projects with proven strategies, rich functionality, and known performance. The application code contains the code that which controls the associated device. This code is embedded in an add-on instruction, AOI, which can be instantiated multiple times in a given application. The graphic objects are used to build HMI displays. There is a selection of global objects available for each process library element, and these global objects can be imported into displays and provide visual feedback to the user. Clicking on these devices will launch the associated faceplate. So here we have a motor function block, which correlates to this motor object, which when you click on that, it has your faceplate for control, alarms, etc. And here you have an interlock object, and so we'll kind of get into that, but you know, each object is provided with an importable add-on instruction and then becomes a native instruction in the application development environment. And the add-on instructions can be utilized by any compact or controller. The global objects for rapid development of information-rich operator displays. The library provides a collection of displays that are linked to the add-on instructions with a drag-and-drop wizard, which allows a rapid application development. And the faceplates. All the objects have an associated faceplate, which appears when the global object is clicked, and these faceplates require no additional configuration, and that's really the beauty of it. So it talks about reducing engineering time. You know, I'm not gonna lie, it does take you guys, it does take a little bit to kind of get started and get the hang of it, but once you guys do, I think you guys will find that it is really awesome, and that's why I'm here sharing it with you guys, so you can kind of skip that learning curve that I had to go through, and if I just share it with you guys, maybe it'll be a little bit easier for you guys to get started. So creating your PlantPAx system application using Studio 5000. Double click the Studio 5000 architect. So let's open this up. This is the first step. We're actually getting into it now. So we're going to go to all programs, and we're going to go to Rockwell software, Studio 5000. Where are you? We're going to do a new project. Architect. What are we going to name it? Oops, we wanted to do distributed architecture, single process server. Okay. I'm already messing up. So I am recording this live, but I think once I'm done, maybe it would even be better to kind of go through and edit this. But editing does take a long time, and I just find that I do better work when I go live. So, except for when I make mistakes like this. Okay. All right. So we're gonna go back to Studio 5000. Oh, it's right here on the desktop. What the heck? New project. All right, so which kind of project do they want? Distributed architecture, single process server. What do they call it? Lab. All right, we're gonna call it lab. I'm gonna try to follow along as closely as possible. And you know, I definitely recommend you guys go through this process as well too. because I do think it's important to do it. But if you guys are just interested in watching along before you guys get started, then that's cool too. So I have done this once before. So there is a couple spots where I found that the manual didn't quite match the library. Maybe there was an update since. So it did take me a while to figure that out, but I'll help you, spare you guys that trouble. But also, having gone through it once, I'm going to be able to go through it a little bit quicker this time. Or at least that's the plan. Okay. All right, so we're a lab. So the architect palette appears with a layout and the predefined controllers for the selected template. As a starting point, the layout pages in the architect software let you draw and connect your components. Each system template has predefined layout pages that show your control hardware layout. The chassis, controllers, communication modules, I/O modules, and HMI servers, panel view terminals, and network switches. Servers, terminals, and communication modules are connected to the network trunks. So here's our system. So this architect project template is pre-configured with 5 controllers. Rockwell supplies various templates as starting points for engineering for a project. They can be downloaded free from the Rockwell Product Compatibility Center here. For lab purposes, let's suppose we do not need controller racks LGX C04 and C05. Hold down your cursor, draw a rectangle, and delete them. So let's go ahead and do that. Notice the controllers were removed from the hardware diagram as well as the list of projects in the Explorer pane. Importing an existing controller project into Architect. We can also import an existing controller project into our Architect project. Prior to the lab, we created a Logix controller file using the basic library template, which includes a subset of the Rockwell Automation process library add-on instructions. For lab purposes, we have added the code for process and I/O simulation. To import this existing project, right-click on Projects and select Add and Add Existing Project. From there, we're going to browse and go to this file location. It's PAC01. Hit Open. OK. 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 Add existing project, browse, we'll go to that location, PAC01, open, okay, it's going to pop up this faceplate. And there we go. So now it's basically telling us all the changes that's going to be added. And it's taking everything from that RS Logix 5000 project, our Studio 5000 project, and bringing it in. And this is the devices that it's going to create. And we'll say OK. And we'll see, it should pop this up somewhere. Wait for the new controller rack to appear in the hardware diagram. Hold the cursor down and draw a rectangle around the new controller rack to highlight it, and then drag it to the lower right corner of the diagram. The imported project contained a 7-slot rack controller with Ethernet communication module in slot 1 and 1756L75 processor controller in slot 2. Slots 3, 4, and 5 contain I/O modules for analog in, out, and digital out. Your hardware diagram should look like this. Connect the new controller rack to the communication Ethernet switch by clicking on any open port on the switch and dragging the connection to the communication module on the new controller rack. Connect the green dot to the green dot. Let's go ahead and do that. So here's our controller. We're going to select it, drag it down here, hold control, click and drag. Oh, no. Click and drag. How do we do this? Connect the new controller rack communication to the Ethernet switch by clicking on any open port on the switch and dragging. Okay, so we're going to go the other way. Click on the switch and drag here to the ENT module. Oh. Don't want to do that. Click on the port on that little green dot, drag it to the communication module in slot 1. I think it's in slot 1, right? We got to go right to this little guy. There we go. All right, now we're connected. The Studio 5000 Architect project can be used to quickly define the controllers, logic applications, and the servers, studio applications that comprise the PlantPAx DCS. It can help reduce the engineering time to assemble your integrated architecture and process application. Changing controller properties using the Studio 5000 Logic Designer. Controller properties and code can be modified using Studio 5000 from within the Architect application. Open Studio 5000 Logic Designer by right-clicking on PAC01 controller in the Project Explorer pane and select Open Project in Designer. This part is actually really cool. So we click on our controller here, and we can open up that PLC project from within Architect. So like Architect is kind of the one application to kind of rule them all. And you'll kind of see further on in the module, we're gonna actually do the same thing, but with FactoryTalk Studio. So it's a pretty cool concept. I really like it, and it kind of helps you. You're gonna still do a lot of the configuration in here, in Studio, and in the other Studio FactoryTalk Studio. But it's just nice to have that central configuration point. Wait a short time for the Studio 5000 Logic Designer to open. Changes can be made to the ACD file from within the designer, and then those changes can be synchronized with the Architect. And as an example, let's change the controller type in PAC01. Click on the controller properties to launch the controller properties and change controller. Then change it from an L75 to an L74 from the controller type drop-down menu, then click OK. Click yes to confirm the new controller type. When the controller change is complete, save the controller. Synchronizing a layout updates all the changes made in associated Logic Designer or FactoryTalk View application into the Architect software components files. Any differences in the Architect components are overwritten. To synchronize a layout, maximize Studio 5000 Architect window. Then from within the Project Explorer pane, expand the Hardware Diagrams folder, right-click PAC01, and then hit Synchronize. So let's go ahead and do that. So we're going to go to the controller properties. Then we're going to go to controller type. I clicked the wrong one. Change controller to an L7-4. Hit OK. Yes. Just changing the controller. Hit OK. Then we'll hit save. Then we'll go back into Architect, right click the PAC01 and synchronize project. So that's going to take the changes from Studio 5000 Designer and push it back into Studio Architect. Wait for the Synchronize Summary dialog box to appear. This may take a minute. Review the changes that will be made to the layout, then click OK to continue with the synchronization. When the Ethernet configuration dialog box appears, review the Ethernet connections, then click OK to accept the current Ethernet configuration. The results of the synchronization are shown in the results pane. A message will appear in the results pane indicating that the sync is complete. Section Summary. The Studio 5000 Architect application can be used to quickly define the controllers and servers that comprise the PlantPAx DCS. It can help reduce the engineering time to assemble your integrated architecture and process application. So there we go. There's the synchronization summary. We'll hit OK. Here's the Ethernet summary. Then we'll hit OK. And in a second here, it should say synchronization complete. And we've pretty much finished the first section. Once this is done here. Let's give it a second. Yeah, you can see that the catalog number is now an L74 for this project. Synchronization complete. There we go. Okay. Organizing the controller and importing strategies. In this section of the lab, you will learn how to organize and configure your controller using pre-configured process strategies that are imported as routines into a controller application. Maximize the Logix Designer window. Let's do that. So we're back into Logix. Maximize. The controller is separated into tasks that run at different execution speeds from a fast 50 milliseconds to as slow as 10 seconds. These tasks are named A through H. The tasks allow us to make better utilization of the processor terms in terms of execution time. The traditional controller organizer window is used to view the controller from an execution and utilization perspective. Click the controller organizer window. This controller file has been configured using the basic library template. The basic library template includes pre-configured tasks and main programs to be used as organizational containers to speed up engineering time. So these are the tasks, and each one is already configured for that cyclical task period. And the reason why you want to separate those tasks is to, like it said, make better use of your CPU utilization. So let's go to controller organizer. And here's the tasks. So this project template is available. So if you're going to start programming, this may be a good place. This project may be a good place to start. The logical organizer is a new feature in version 24, whereas the traditional controller organizer is used to view and configure the controller from an execution and time and utilization perspective tasks. The new logical organizer provides a way to view and create organizational model of the system, programs, and routines. This allows operators and maintenance to troubleshoot the system more quickly, while new features such as selecting multiple project components like AOIs, UDTs, programs, and then copy and paste, drag and drop, export, import them as as 1 to reduce engineering time. For this lab, we will work in the new Logical Organizer window. Click the Logical Organizer tab. Notice that a diagnostic task is included in all controller templates. This task allows for troubleshooting, reporting, and alarming of controller status and utilization. Note that there is a pre-configured code for the lab simulation in task C running at 250 milliseconds. Since we are in a lab setting and not connected to real I/O, simulated I/O has been added to this template. In this section of the lab, we will add a new code for a tank, including a pump and level transmitter to task D running at 500 milliseconds. We will rename the main program in task D from task D main program to tank 1. Double click on task D main program to open the program properties window. Change the name to tank 1 and then click OK. Let's go ahead and do that. So we're going to go to Logical Organizer, Task D, Task D main program, right? There we go, we'll just call it Tank 1. Okay. Program is renamed to tank 1 and is running at a 500 millisecond task. Now we will add new code for the tank, including a pump level transmitter. Engineering the controller using process strategy routines. Process strategies from the RA Library of Process Objects support the concept of reuse of engineering time to save time. Starting from a pre-configured and tested control strategies that are imported as routines into each controller application, we save engineering time. By organizing a controller into programs, for example, each tank is a program, routines, levels, pumps, and valves, we simplify the location of a desired piece of code and can reuse code in a line with best practices and standards management. Later in the lab, because we organize the controller by tasks, programs, and routines, we can easily copy the code for a completed tank, including all components like AOIs, UDTs, routines, tags, and then paste it as 1 to create more tanks to reduce engineering time. Importing a process routine for a pump. In this section, we will import a pre-configured process strategy for a PS motor into the program named tank 1. A motor can drive a blower, conveyor, mixer, agitator, or a pump. We are configuring a pump to fill the tank. Right-click on the program named Tank 1 and from the menus, select Add and then Import Routine. Browse to the Process Strategies folder and select the file for a motor. So under Lab Files, Logix 5000 Process Strategies, PS motor. We're going to import that. So we're going to go import routine, and we're going to select under Lab Files, Process Strategies, PS motor. Hit OK. The import configuration window will open. From this window, we can configure the new routine during the import process. First, change the final name for the routine from MT100 to pump. Do not click OK. The import content area of the configuration window, click on the tags and folder to view all the tags that will be imported. We want to modify the tag names by replacing the generic MT motor designator with PMP during the import routine. The MT is a default tag designator for any type of motor. A motor can be yes, we already heard that, a drive, blower, conveyor. In this case, we're designing a pump using PMP in the tag names. Click on the Find Replace. So we're going to first rename it to pump and then find replace MT with PMP and hit replace all. Final name, pump, find replace, MT with PMP. Replace all. 7 occurrences found. Okay. Okay. Wait for the import to complete. Once the import completes, a new routine named pump is added to the tank 1 program. Double click on the pump routine to open the function block editor to view the code. Verify all the instances of MT have been replaced with PMP in the tag names and input output references and connectors. The pump control routine is complete except for that the input output references connectors need to be associated to simulation tags or IO channels. So here's showing that everything was replaced. Let's double check that it did that for ours. And here we have our process strategy in a function block code. Here we see we have the P motor PlantPAx AOI. Here we have the P underscore runtime, which automatically has start counter, runtime, and then a restart inhibit. So like a backspin delay. A lot of functionality built into these guys. It's awesome. So this is be something that you guys would kind of set up, have a standard for, and like you see, you can real easily import, export, change it from MT to PMP or drive or 100 to 200. You kind of see how that could really reuse your engineering work. So let's go back and see what they want us to do next. Later in this section, we will use a new feature called program parameters to connect the input-output reference connectors while the controller is online using what's called late binding. So let's import a new routine for level indication. So we'll go through that same process, add import routine, and this time we'll select PSA in. From there, we'll change XT to level, and we'll find replace XT for LT and hit OK. So we're going to go add import routine, PSA in routine. And we're going to change the generic name to level. And we're going to find and replace XT with what now? With LT. Replace all. Close. Okay. Wait for the import to complete, and then a new routine named level has been added. Double click on the level to view the code. Verify that both tag names have been replaced, and we're going to bind the IO later. We'll now use program parameters for making the connections. So let's just double check that this looks good. There's our level routine, and it's inputted LT 100. Cool. Connecting to IO or simulation using program parameters. We will use a new feature called program parameters to connect input-output references. First, we will connect the IO reference connectors to the simulation code. Simulation code for a pump and level has been added to test the new control strategies and new HMI graphics. Later in the lab, after the testing is complete, we'll use late binding of program parameters to connect to the control strategies to the hardware input and outputs with the processor online. Program parameters can be used to associate or connect the IO reference connectors to physical IO or simulation code, and then they can be changed while the processor is online. Alias tags, which you guys are probably familiar with, can also be used as to associate to connect the IO reference connectors to physical IO or simulation code, but they cannot be changed while online. It's good to know. Configuration for the 3 hardware IO modules has already been added to the IO tree. Slots 3, 4, and 5 contain analog in, digital in, and digital out. The modules have been inhibited because we are running code in our emulated processor. We will connect the IO modules channels later in the lab. To view the local tags to tank 1, click on parameters and local. So under this program, tank 1, parameters and local tags. The program parameters allow you to associate tags with the I/O while online or offline, and later we'll associate it with the I/O while the controller is online. Let's see how this tag and I/O association is done. To associate the tag LT input PV tag to a simulated analog input level for testing, click on the drop-down menu arrow in the connections column for the tag LT input PV. In the tag list, navigate to simulation tag / /tank1 sim level and double click it. Let's go ahead and do that. So LT input PV, connections, tank 1 sim level. Parameters, LT input PV, we have the connections column, hit the drop down, tank 1 sim level, hit enter. Okay, now what do we do? To associate the pump tags to simulation, do the same thing, and we're gonna do that for pump input run feedback and pump out run. Okay, there we go. Okay. Program parameters section summary. So the program parameters are configured for late binding. We connected to them to the simulation logic for testing the HMI application. Later we can change these to the actual I/O while online. Adding code to execute new routines. Next we need to add the instructions to execute the new routines. We'll use this by using a jump to subroutine instruction and to execute the pump and level routines. So we're going to go into tank 1 main routine and add in JSR to the tank and level, the pump and level code. So we're going to add rung, JSR. Okay. Pump, copy, paste. Right, so we just want to have JSR pump, JSR level. Then we're going to, all right, I'm getting too far ahead. So we're going to go back to main routine. See, this is the task monitor that was already created. This is the simulation that was already created for us. So we're just going to add a rung, JSR level. And we're going to add another one, JSR pump. Nope, let's delete this. Okay, save. The coding for tank 1 is complete and ready to download to the controller. In the upper left of the Logix designer, click save and click on controller status button and select download. RS Logix 5000 is RS Logix Emulate 5000 software is an engineering tool that is capable of emulating a Logix controller. For this lab, RS Logix Emulate 5000 software is already running and the chassis has already controller configured in slot 2. We want to download to the emulator controller, but first we need to change the controller type. Click on change controller type and then in the project to connect to an emulator controller. Click yes to confirm and wait for the project to upgrade. Let's do that. So we're going to go here, download, change type, changing from L74 to emulator, yes. From this point forward in the lab, we will no longer be able to synchronize the project with Architect since emulator is not a supported controller type in Architect. Click download to start the download. Wait for emulated controller download to complete. It may take a few minutes. Download. For this lab, RS Logix 5000 RS Logic's Emulate 5000 software is already running, and the chassis already has a configured controller in slot 2. Click yes to change the controller to remote run. Okay. Let's change the controller back to run mode. Okay. Verify that the controller status button is green to indicate remote run. Minimize the Logix designer. So in this section summary, the new logical organizer provides a way to view and create an organizational model of the system. Application controller templates are available with preloaded library content to start your logic project. Process strategies were used to quickly add pump control and level indication code to the project, supporting the concept of reuse engineering to save time. All right, now we're going to configure an HMI project. So we're going to minimize this. We're running. Okay, cool. And here is our Logix emulator chassis monitor. So let's configure an HMI project. In this section of the lab, you will learn how to create and configure your logical servers, data, HMI, and alarms. All of these software components are assigned to a PAS server, Process Automation System Server, I believe. You will also use FactoryTalk View Studio software and an HMI project template to provide a starting point for your HMI project. You will then create a graphic screen containing a pump object and a tank level object, which will be used to test our controller code. Choosing an HMI template. Application templates are included in the RA library for a starting point for HMI applications. 3 ones have been provided depending on the display resolution. All of the above HMI templates include the following attributes: basic display layout, navigation, alarm, and alarm displays. However, HMI templates do not include the library objects. The library objects must be imported into the project separately. In the following lab section, we will build HMI objects and displays through drag and drop procedures in Studio Architect. Importing an HMI template into Architect. So return to Studio Architect. Studio Architect has a Project Explorer window on the left side and a Library Management window on the right. Rockwell supplies a set of library templates complete with displays, global objects, images, and macros in the form of HMI templates. The library components can be dragged from the Library Management window into the project areas of the Project Explorer window. The displays, global objects, images, and macros from the HMI template and process object library will now be added to your the view project in your Architect application. So here we have the library on the right and the project on the left. So in the library management, we're going to expand libraries, process library 3.5, templates, FactoryTalk View SE. We're going to grab the P1F template 1920 by 1080 full HD. And we're going to expand our PlantPAx area. And we are going to drag that right onto the PlantPAx HMI folder. So let's do that. Open up Architect. We're going to expand process library. Process objects, FactoryTalk View SE. No, where is it? Templates. That's where it was. Templates, FactoryTalk View SE. And then here's our P1F template, full HD. We're going to expand PlantPAx area, PlantPAx HMI, and we're going to drag this right into here. There we go. We added all the displays. We added all the global objects and images. So let's see what we got to do now. The displays, images, and macros from the HMI template have been now added to the View project in your Architect application. In the library management pane, expand libraries, process library objects, process objects folder, and drag and drop the FactoryTalk View SE folder from the library management pane into PlantPAx HMI folder. So the same thing, but process library objects. So process library objects, FactoryTalk View SE, drop that onto PlantPAx HMI. Yes, we'll replace it. Is it asking us if we want to do that? When you are alerted that a component already exists, click yes repeatedly to replace the existing components. This may appear many times, and then it's going to look like this. Okay, so now we should see our global objects here now. Sweet. Okay. Section summary. So the displays, images, and macros from the HMI template and the global objects and images from the process library have now all been added to your View project in your Architect application using simple drag and drop library management. It's really cool, guys. I think that's awesome. You can kind of, leverage the built-in library. You can create your own libraries and just kind of drag and drop what you need into your project real easily. So now we're going to be configuring the HMI data and alarm servers for the PlantPAx system. The HMI servers serves the graphics up to the operator display clients, and the data server handles the communication of the data to and from the controllers, and the alarm server handles all alarms and events. Each of these software servers is within the Architect application needs to be configured. So let's go configure the HMI server. Scroll down to the bottom in the Project Explorer and click plus to expand the hardware diagrams folder, and then expand the process area. Right click on pass one and then click properties. So hardware, diagrams, process, pass, properties. I'm going to minimize that. Process, pass, properties. Okay. So, okay. The computer graphics properties dialog box will open. On the general tab, verify that the graphic name is pass01. On the device tab, type the computer name that hosts the pass. In this lab, the computer name is ASE01. Type in the name and hit OK. So here we see on general, the graphic name is pass. Device is not pass, it's ASE01. Copy paste didn't work. ASEWS01. ASEWS01. Okay. ASEWS01. Configuring the data server. In this section, we will create a shortcut on the data server to connect our controller. Observe the communication pane on the bottom left corner. Notice that currently there is no controller connection configured. We will now configure the controller connection. On the process area hardware diagram, drag the communication module from the PAC01 chassis slot 01 and drop it onto the PAS server. So we're going to go from the communication straight to the PAS. Let's go ahead and do that. So there's our PAS. I'm going to drop this here. Boom. And it's going to say configure. What are we going to do here? When the communication module is dropped onto the PAS server, the configure module dialog box appears. Leave the defaults and then click OK. OK. Notice that the communications shortcut is updated with the communication module name. So let's see where this is. So in here we have the communications pane, which you guys, I don't know if you guys can see this. I don't know. Let's see. Yeah, so there it is right there. Notice that the communication shortcut is updated with the communication module name. Drag the controller from the PAC01 chassis to slot 2 and drop it onto the PAS server. So now we're going to do the CPU. Add new or modify existing shortcut dialog box appears. Leave the default values and hit OK. Notice that the controller shortcut now appears in the communication pane. Note, we will modify the shortcut later in the lab to point to the emulator controller. Save your Studio Architect project. So we'll say OK. And there we have the shortcut to that L74 processor. So basically that's just linking the shortcut. So you guys are familiar with FactoryTalk View SE. It's kind of like the access path for where it's getting that data. And then so it's kind of like a shortcut, and then you use that for your tagging. So just by dragging and dropping it there, you see how that was really easy to configure that shortcut. I think that's really cool. We'll save. Okay. Now we're going to configure an alarm and event server. In the Project Explorer, expand Labs, Projects, PlantPAx Area Alarm folders and right-click on PlantPAx AE and select Properties. Okay, so under PlantPAx Alarm, PlantPAx AE Properties. The tag alarm and event server properties dialog box appears. Studio Architect defaults the alarm name and host computer. In the general tab, type a description such as Lab AE Server and then click OK. Lab AE Server and then click OK. The alarm and event server is configured. We used Architect to configure the servers. Committing a project pushes all the configuration changes made it in the project in Architect to the associated Logix Designer or FactoryTalk View project file. In this case, all of the server configurations are pushed to the FT View HMI application. Right in the Project Explorer, right-click PlantPAx and choose Commit Project. Right-click PlantPAx, Commit Project. Click OK in the Commit Summary dialog box. Click OK. Committing the project pushes all changes made to it in Architect into the associated Logix Designer or FactoryTalk View project file. Any differences in the project file are overwritten. Wait for the project to commit, and it could take a few minutes, and when it's done, click Close in the Commit dialog box to complete the configuration of the servers. the project is committed. So in summary, the HMI server, data server, and alarm server were configured in Architect. Then we committed the configuration changes made to the project in Architect into the associated FactoryTalk View application. Using FactoryTalk View Studio to develop and test the HMI application. FactoryTalk View Studio is configuration software for developing and testing PlantPAx HMI applications. With FactoryTalk View Studio, you can configure a single operator station or configure an entire distributed application from one location, access tags via tag browser that presents direct PLC tags and HMI tags in a logical hierarchy, remote configure FactoryTalk View site edition servers, create displays and faceplates using a full-featured graphics editor. In the Project Explorer of Studio Architect, right-click PlantPAx and choose Open Project in Designer. This will open FactoryTalk View. Wait a short time while FactoryTalk View Studio application opens, and when it is open, expand PlantPAx area data PlantPAx dat folders, and then double click on communication setup. PlantPAx. PlantPAx dot. PlantPAx communication server. Communication setup. The pack controller shortcut is currently directed to the L74 processor that we configured in Architect. Since we're using the emulator tab, we need to redirect it to the emulator. So let's go back to here. Open up the communication setup. With the pack 1 shortcut selected, expand the virtual backplane of the 1789 A17 and select RS Logix 5000 emulator in slot 2 and click apply. With this selected, expand that, hit this. Looks like it's already set for that. So like if it was for this or something, we would go here, apply, yes. Then we can go back to this, apply. Okay. So we want this RS Logix emulator, boom. That's what it is. Okay. Click yes to confirm. Okay. Click OK to accept the changes. Okay. So basically we're just pointing that device shortcut to this RS Logix emulator and hitting apply. If it applies grayed out, that means it's already set to that. And you've made those changes. So click OK to accept the changes. The communication setup can be configured within the Studio Architect software, but the lab settings we're using emulator, which is not yet supported type in Studio Architect. Using library global objects to configure HMI displays. Expand the displays folder and scroll down near to the bottom of the list of displays until you find display name P1F Home, where the P1 stands for Process Area 1 and the F in this graphic is configured for full HD. Double click on the display named P1F Home to open the display editor. I learned something new. So now I'm working on a project that has 7 different process areas. So I'm actually going to start naming my screens P1 system overview, P2 system overview, P2 detail, things like that. P7, you know, pump control screen. So I think that's really cool. You learn something new every day. Double click P1 home to open it, and let's go do that. Displays. These are all the pop-ups, and then down here we have P1 home. Okay. And the display is blank. We will start with the display because navigation to it is already configured on the template navigation button bars. The next step will be to add a pump and level object for tank 1 to the display, and then link the objects to tags in the controllers. The easiest way to do this will be to use the global objects. The global object is an HMI display element that is created once and referenced multiple times on multiple displays in an application. When changes are made to the original base object, the instantiated copies are automatically updated. In the Explorer window, expand Global Objects folder, scroll down until you find a global object named RABAS P-Motor Graphics Library. The RABAS stands for Rockwell Automation Base Library, and the P-Motor means the screen contains motor objects for process control. Double click on the RABAS library to open the display editor. Global Objects, RABAS, Motor Graphics Library. So there's our Motor Graphics Library, and these are all the different pumps graphic objects that we can use. For rapid development of information-rich operator displays, the Rockwell Automation Library of Process Objects provides a collection of global objects that are linked to the add-on instructions with a drag-and-drop wizard. Display elements include motors, valves, analog and digital indicators, and even a sequencer. Together with the HMI Project templates, they allow for rapid development of display graphics. Drag and drop a pump object from the global objects display to the blank P1F home graphic. So we're going to grab this pump object and drag it right there. Boom. Okay. In the Explorer window, search in the Global Objects folder until you find the PAIN object. This is for the analog input section. Open it up, and we're going to drag this trend on there. So PAIN, these are all the analog objects. We're going to grab this trend and drop that bad boy right there. Right click on the pump object and open the global object parameter values in the selection menu. Right click, global object parameter values. The global object parameter value window is open. We need to enter the tag value for the motor into parameter 1. This parameter links the tag PMP100, the tag that we created earlier in the logics code, to the instance of the pump object. For parameter 1, click the ellipsis button, column name tag, to open a browser window. The tag browser window allows you to access controller tags via a browser window that presents the controller tags in a logical hierarchy. Click the refresh all folders button. Expand the directory named PlantPAx area data PAC01. PAC01 is the data server shortcut named for the controller in slot 2 in the emulator. Then expand the subdirectory named online. Area data PAC01. Online, and here we have the PMP01. So there's the selected tag. Notice it's /area/data : in brackets PAC01 PMP100, and click OK. Click OK. Click OK once more to accept the parameter. Right click on the new analog object, and we're going to do the same thing, but for the LTO1. Global object parameter values, object tag, LTO1. Okay. Okay. Click on Save to update the P1F home display. This display is functional but can be customized with tanks, piping, and other and more using the included Symbol Factory HMI library. The Symbol Factory, I'm sure you guys have all used it. It's over 5,000 graphics. we're going to drop on this tank symbol. So we're going to go to Symbol Factory. We're going to go to tanks. And I don't know, I like this tank right here or something. Right click, arrange, send to back. Kind of center these objects. Arrange, align middle. Oop, that's not what I wanted to do. Control Z. I want to align center. Arrange, align center. Okay. There we go. Using the symbol factory. I just showed you guys how to do that. You drag it on there. Boom. Send it back. Save. Okay. I kind of just skipped ahead because it's pretty simple. Section summary. For rapid development of operator displays, the Rockwell Automation Library of Process Objects provides a collection of global objects that are linked to the add-on instructions with a drag and drop wizard. Together with the HMI Project templates, they allow for rapid development of display graphics. Using FactoryTalk View SE Client to view the application. The application code and HMI is finished. Tested by running the FactoryTalk View SE Client. FactoryTalk View SE Client is a software for viewing and interacting with the FactoryTalk View SE application at runtime. Operators can use the client to view, interact with multiple graphic displays, manage alarms, view trends, and adjust set points. Create an operator workstation client file. From within FactoryTalk View Studio, select the Tools menu and choose Launch SE Client. Then we're going to click New. So Tools, Launch SE Client. We're going to go ahead and create a new one. From here, we're going to type Lab. And we're going to save it in the default folder. We're going to hit Next. And we're going to select Network Distributed. Hit Next. From here, we select the application, PlantPAx. Next. On the area, select Area, PlantPAx Area. Okay. And we're going to run a startup macro P1F client. So this basically macro in there has like the default displays that you want to open. You can open an initial display here, but it's only one. This startup macro has others built into it. And we're hitting Next. We're going to uncheck Show Diagnostic List and hit Next. And then we're going to hit Next. And we're going to save and we're going to hit Finish. Now it's going to run it. I'm getting a little carpal tunnel here. Let's see. Looks like we are just over an hour and 11 minutes in, and we're pretty much like halfway done. Probably more than halfway done. Cross your fingers, hope this works. Oh, I forgot to hit save, you guys. Save. Open this up and then hit refresh. Move this over here. And there it is. So There's our pump, MT100. There's our level, and we can click on it. It'll open up our faceplate, and here we can do start and stop. Here's our runtime, restart inhibit object, our runtime object, permissives, interlocks, start, stop, operator mode. We can go into program mode, maintenance tab, engineering tab, diagnostics, alarms. So I mean, all this is already all set up. Like, didn't have to do anything. We didn't have to like even go inside of the controller code. Now I think it's like important to like know how to do a pump AOI. I think that's an important process to go through, but after you learned it for just the sake of learning it, no reason to go through each project that you do and create your own add-on instruction. I know probably everyone has their own libraries that they use or copy and paste from previous projects, but why not use a library that's standardized for Allen Bradley, has a ton of features built in, has nice faceplates. So, I think it's pretty awesome. So let's get back to the lab here. Okay, finish. Okay, boom. When the client file opens, your application window will display the layout of the selected template. Notice that the docked header and footer displays, they are also part of the framework displays contained in the HMI template that also includes button bars and alarm history for help displays. The template header graphic is used to display information that will be always visible to the operator, such as current day and time, name of the current area, general alarm, and system status and navigation buttons. Now we are ready to test our application by starting the pump and emptying the tank. Click on the pump to open the pump operator control faceplate. Click start. Start. There you see the pump is starting. Now it's running and it's draining our tank. When the pump starts running, verify that the tank empties. Note the tank will automatically reset to 100% once it empties below 1%. So that's kind of going down there. And this also has its own graphical faceplate. So here, we can see everything about the level. Here we have maintenance, alarm settings, set points, engineering, label, tag, a long description which shows up in the header, and enable a navigation to input channel object. So if you had an input channel that detects faults, you could navigate directly to that. Here's your trend built in, and alarms, which none are enabled right now by default. So let's go back. Add a section summary. Reuse code easily using the logical organizer. So now we're going to jump back into the Studio 5000. The new logical organizer provides a way to view. Yes, we already talked about this. So we're going to maximize the logic designer window. Go back into designer. In the previous section of the lab, we made logic code additions offline and then loaded the controller. In this section, we'll be making code changes online to the running controller to demonstrate how code can be added without interrupting the operations of a running plant. In the logical organizer window, right-click the program tank1 and click copy. Right-click on the controller PAC01 and click Paste Special with configuration. Wait for the import configuration window to open and change a file name from tank1 to tank2. Do not click OK yet. Schedule the new tank2 program in the task D500 milliseconds using the dropdown. Click on the tags folder in the import content window area and do a find and replace for 100 to 200 and then click OK. So we're going to wait for this dialog to open. We're going to schedule it in. Well, first we're going to say the final name is going to be tank2. And now we can schedule it in task D. And then we're going to go to parameters and tags, find and replace 100 with 200, replace all. close. Okay. And let's see what it says here. Because the controller is running and we're making edits to the code online, we will need to choose how the edits will be imported. Check the selection for finalize all edits in program during the import and click OK. Okay. Wait for the import to complete and verify that the new program named Tank2 has been added. Adding Tank2 to the FactoryTalk View Studio graphic. So here we have the Tank2, you know, we're still online and we can look at the pump 200. We could look at the level 200. We're gonna go back into Studio and we're gonna group this object. On the P1F home display, use the cursor to highlight Tank1 objects and click Arrange in the editing selections on the upper menu. Click Group from the drop down and this groups the objects. Close this. Nope. Nope. Open up P1F home. Select. Arrange, group. Right click on the group tank and click duplicate. Position the new tank to the right of tank 1 and select right click the new tank group and select tag substitution. In the tag substitution, search for 100 and replace with 200 and click the replace button and replace all. And then click OK and hit save. So we're going to duplicate and move it over here. We're going to arrange, align middle. We're going to right click, tag substitution, search for 100 and replace with 200. Oh, 200. Replace all. Okay. Then hit save. I'm going to go back to our view application and resync. I don't know why it doesn't. Doesn't save the home changes until I. So weird. There we go. Here we have pump 2 stopped and we have pump 1 not stopped. But notice now the description is still saying motor 100. So we're going to go in and fix that right now. Testing the code. Yep, so we went back into FactoryTalk View Client. On the lower lower corner of the View Client screen, we click the refresh button, and now we see it. And verify both tanks drain. Okay, we could start this one. Now it's starting. Now it's running. Okay. Notice that the labels and descriptions are still referring the XT100 and MT100. So now we're going to be commissioning the device faceplates. In this section, you will configure the device, the tag, descriptions, labels, and interlocks for the new tanks. We will focus on tank 1. If you have the time at the end of the lab, you can go correct tank 2 as well. And there's actually a spreadsheet that you can configure many objects at once, and there's a macro that will then go write that tag through RS links to the PLC, which I have yet to set up, but I can imagine it'd be pretty sweet for like if you had 100 pumps. You don't want to go into each one and type it in. You want to just store that in a spreadsheet. So from the FactoryTalk View Client, click on the home screen button and on the bottom, on the button bar to display the tank string if not already displayed. Notice that the labels and descriptions for the levels still reflect XT and MT100. Click on the tank 1 level indicator to open the PIN faceplate. Click on the engineering tab. And from here, we're going to change it to tank 1 level and LT100. Engineering tab. Whoa, what's going on here? Okay. To make changes from the engineering tab, the user must have the appropriate access rights. Due to time constraints, we will not be addressing security in this lab. The current login administrator has the highest level of security access. Notice the description at the top of the faceplate and the label have also been updated. So you got to hit enter also to actually have those right. So now you see LT100, tank 100, and you'll see it right there, LT100. So let's just go ahead and do that for XT100 as well. So on engineering tab, we'll call this tank 2, right? Enter. LT200. LT200, hit enter. Close that. Okay, cool. On the alarm thresholds tab for tank 1 for the tank 1 level also needs to be configured. Click on the maintenance tab of the alarm faceplate This tab allows us to change the alarm set points, change the PV low alarm threshold to a value of 1. Engineering, alarm value. Click on that, it'll open this. 1, apply, okay. Okay, there it is. In this lab, we're just configuring a single alarm limit, but there is a PlantPAx alarm configurator tool available for configuring a large number of alarms. We still need to activate the alarm. Click on the alarm tab of the faceplate. Click on the low alarm, which will open up this alarm faceplate. Engineering. The alarm is configured to exist and will be scanned. Click the box for the alarm is configured to exist and will be scanned. Notice that once the level is below the low alarm threshold, the alarm will activate and the alarm box will flash red. Click the alarm tab and you will see that the low alarm is now activated for tank 1 level. Okay, there it is. Now you see it's all active. And if it's running, we should see this. Once it goes below 1, we should see it pop up. Click the alarm acknowledge button and the alarm indication will stop blinking. It will remain red until the alarm condition clears. So in just a second here, we're going to go past that and it should, you'll see how the alarms are handled. This is one part that I didn't really get. This whole click on the reset tank levels button. I totally missed where we added that, but reset tank levels button. Yeah, I missed where we added that, but that's okay. There we go, boom. So now you see it's flashing, so we can acknowledge it, and now it went away. Close the tank 1 faceplate, click on tank 1 pump to open the device faceplate for that. Click on the pump. Open the engineering tab. We're gonna go motor 100, MT 100. Oh no. Tank 1 pump and PMP 100. Note, the motor process strategy that we used is pre-configured with motor run feedback, permissive, interlock, and restart inhibit objects enabled. If we did not need these for application, we could disable the functionality for this object by removing the appropriate checkboxes on the faceplate of this tab. We will keep this functionality in your application. That's something to note, is if you just grab the library, this motor has run feedback checkbox is not checked by default. And also these enable navigations to permissive objects that, so this is not the default setup. This is what that process strategy was set up. But, you know, like once you set it up how you want it, then that's the idea, is that you don't have to do that again. Configure an interlock. Since pump 100 is still running and the tank level will decrease and a low level alarm will become active again if the pump is stopped and wait for the tank level to drain. Although the tank is empty, the discharge pump continues to run. Let's configure an interlock that will stop the pump on low tank level. So we're going to go here. We're going to go to the interlocks. First, we got to go. Okay, we got to go to the open up Studio Logix Designer. We'll go to pump. We're going to go to sheet 3, which is our interlocks page. This process strategy has been configured with the interlock object. However, no interlocks have been configured. Let's add an interlock. To make changes online, click Start Pending Run Edits button. Add an input reference and connect it to the input interlock 00 object. Double click on the input reference and type LT100 STS low low. Finalize all edits by clicking the Finalize button in the online toolbar. Maximize the FactoryTalk View client window. Return to the home tab of the pump faceplate. Notice that the pump has been stopped and the interlock button status is now red. So once it goes, oh, it looks like we probably just missed it. The interlock description has not yet been configured to match the interlock configuration that we implemented. Click on the engineering tab. So open the interlocks. Click on the engineering tab. Go to page 2, and this will call, what do they want us to call it? Tank 1 level, okay. Check the box on the left of the interlock descriptor to allow navigation from the interlock faceplate to the interlock input object. Change the text field as shown by hitting the enter key after entering the text. So on the third page, we want to actually be able to navigate directly to that interlock object, or from the interlock object to the input object, which in this case is the LT100 analog screen. So from here, now we should be able to just click on this and it'll open up our LT100 faceplate if we entered it incorrectly. What is going on? Oh my gosh, I did this for tank too. Alright, hold on, I'm gonna start edits. Sorry guys. So now we're gonna finalize that. We're gonna go back. That's why it's not working. Okay, we're gonna go to tank 1, pump, inner permissives. Oh, that's also permissives. We need to go to interlocks. There we go. Start edits. Boom. lt100.sts underscore low. Finalize all edits. Yes. Why is it not working? Did we not bring the macros in? So this nav to object, this nav to object macro is needed for this. Oh, that's why. Got it. Okay. So, see, I'm getting ahead of myself. Okay, so sorry guys, I was trying to navigate to it, but there's a little key step first. It needs to know this path layer. So let's go maximize the FactoryTalk View Studio. Go back to the P1 home, select tank and ungroup, and then we're gonna go to global object parameter values. So P1F home. So basically, all right, so I don't even need to double click. You just double click and then you can select this, go down to global object parameter values and this path. So this path is key for actually making that nav to object work. From here, we're going to type in the path pretty much up until that PNP1, which is basically this. What the heck? There we go. Okay. I'm going to do that for this one too. And I'm gonna just hold off on, well, actually, we could just delete this and just duplicate it. So then that way it's also done for pump 2. See, it should have had us do this first. Now we're gonna go back and make changes. Tag substitution, 100 with 200. Okay. Click save. Oh, shit. Didn't mean to click that. Now we should go here, back to our application, hit refresh. Now we can click on this. The pump is stopped. Interlocks. Tank 1 level, okay. Boom. There you see we have an alarm. Acknowledge it. How convenient is that, guys? Sweet, huh? Oh, I don't know why it's not. Did it stop the pump? Oh, it did stop the pump though. For some reason though, it like overshot and then it kind of then reset. So I don't know. I'm just gonna set it for like I'm gonna set it for like 80 or something so we can see it. There we go. So now you see we have a low alarm on the tank. We have an interlock. I'll click on the interlock. You know, if this was closed, we could say, oh, tank 1 level is not okay. Let's go see what's wrong with that. It'll open this up. Boom. So, I mean, look at all this rich functionality that we've got in like an hour and a half, hour and 38 minutes in. And look at all this functionality that we've got going. Yep, so here you can see we can click on the interlock condition and it'll pop up the level faceplate. I click the acknowledge button to acknowledge the alarm. Oh, it's already open. Okay. Now let's see. Click on reset tank levels. See, I don't have that button. Move faceplates down if they are covering the reset button. Now what is cool is you can actually click on this and you can enable bypass. You can say that this has a allow bypass, can bypass. So let's say that we can bypass it. We can click enable the bypass, and then on here we can click so basically three steps on engineering page 2. We can say can bypass, and then we can enable that bypass, and then the last step is actually going back to the pump itself and clicking I think it's under in maintenance, enable bypass, bypass interlocks and permissives, the ones that you've enabled bypass. So now you can see on the home screen we have bypasses, but we're bypassing them and we can start the pump. So just think about that right there for a second. Like probably 90% of the code that you've written before like doesn't have that feature built in, unless you specifically built it, in which case that would probably take some time. Not to mention like the graphical displays behind that. But like, you know, obviously an operator wouldn't be able to do that without the right permissions. But you know, like let's say you had a bad sensor or something and it was stopping that pump from working, you could bypass that real quick. Or if this was a PDIN object, you could open up that faceplate and you could simulate the input, or you know, there's all these other things that you can do. So you know, here you can see we have all the permissives are good, but the permissives that are able to be bypassed are being bypassed, and it'd be yellow if active permissives or interlocks were being bypassed. Configuration of the tank 1 faceplates is complete. Close open faceplates. Later, if you have extra time, fill a feeder to configure it for faceplate 2. Now we're going to be configuring alarms. In this section of the lab, we will set up tag-based alarms for the use with the FactoryTalk alarm and event software. Prior to the lab, the alarm builder tool was used to generate an alarm import file for the PAC1 controller. Refer to the process publication, process RM2, for more information on the alarm builder tool. Maximize FactoryTalk View Studio. Expand the PlantPAx area alarms folder and click on right click on PlantPAx AE and select import export. Import alarm configuration from XML. Select from lab alarms XML. Next. Update existing. Okay. Now you see we have an alarm here. Cool. A new feature of the FactoryTalk View SE 8.1 is the ability to easily configure and filter on alarm groups. In the Explorer window, expand PlantPAx AE and double-click on an alarm and event setup. Right-click on PlantPAx AE and click Add Group. Call it Tank 1 and add one for Tank 2. Highlight the alarms from LT1, drop it in there. Same thing for LT2. And see, we also have LT. Let's do the pump ones as well. Yeah, whatever. I'm gonna do it right. We'll do tank 3. Drop these 3 in here. I really want to put the pump alarms in here, but I'm not really sure if it's going to try to show us something about them being different, so I'm going to leave it there. I think it does. Click the save icon. Configure an alarm banner. From the Explorer pane, open up graphics displays and double click frame P1F to open. P1F footer. Right click on the display and select properties to access the alarm and event banner properties on the properties dialog box. Alarm and event banners, properties. Go to columns and select alarm name. So we can show that. Then go to event subscriptions, browse. PlantPAx, drill down into alarm, PlantPAx AE, tank 1, okay. Apply, okay. Hit save. For some reason I gotta close this. Yes. Save, okay. Alright, now we're gonna go back here. Now we see that there. Starting both pumps. All right. Start both pumps if they're not already running by clicking on the pump to launch the faceplate and click start. The low alarm threshold for tank 1 was configured in the previous section, but we'll need to configure one for tank 2 in order to view the alarm in the alarm banner. Click on the tank 2 level and open it. We'll go to the engineering tab, the maintenance tab, and set an alarm threshold. All right, there we just triggered that alarm. Close the faceplates and wait for the tanks to drain. Notice that both tank levels now indicate alarm conditions. However, only the tank 1 alarm appears in the banner. This is because we configured the alarm banner to only show alarms in tank 1 group. Click on the alarm summary and then you can see the full thing there. So you see we have, well, where is plant? See, are we getting an alarm here? Maybe I didn't hit enter. Oh, I gotta configure the alarm to exist. Alarm is configured to exist and is going to be scanned. Okay. Let's give it a second here. All right, I'm not that patient. Okay, there we go. Boom. But only the alarm from tank 1 is here. But if we go to the alarm screen, we should see both tanks alarms. Maximize the FactoryTalk View Studio. Open the alarm event spanner. Go back to the P1 footer. Right click, properties, go to this event subscriptions, browse. We're going to add tank 2. Okay. Oops. Apply. Okay. Save. Go back to our app. Hit refresh. Yeah, see, it doesn't do it. Doesn't update the screen unless I actually close the window for some reason, which is really weird. Now we can hit update. Now it's there. I mean, you guys saw that, right? So I don't know what that is. Maybe it's like a setting or something. Yep, add the event subscription for tank 2. Boom, hit OK, save, open it, refresh. Yeah, we did that, it didn't work. We had to close the window for some reason. Now we should see it there. So, section summary. A new feature of FactoryTalk View SE 8.1 is the ability to easily configure and filter on alarm groups. Late bind the I/O parameter tags to I/O module channels. You will now assign physical I/O tags in your project while the controller is running. This capability is also known as late binding through the power of program parameters in Studio 5000, Logix Designer version 24. Users can create projects without worrying about I/O connections during the engineering stage. Maximize the Logix Designer window. I/O configuration for the 3 hot modules have already been added, and we've already mentioned that. To view the local tags to tank 1, click on the parameters and local logic tag parameters. From there, we're going to expand and we're going to tag the input PV to local 3.1 channel 0.data. Local 3.1i channel 0 .data. So now it's connecting to that physical I/O point, and we're going to do that. Boom. You've now assigned a physical I/O tags to your project while the controller is running. This capability is also known as late binding and through the power of program parameters in Studio 5000 Logix Designer version 24. Yes, we already said that. Okay. Lab summary. We're getting pretty close to the end here, guys. PlantPAX is the process automation system from Rockwell Automation with all the core capabilities expected in a world-class modern distributed control system, MDCS. Configure your integrated architecture control system to meet the PlantPAX system guidelines, and you can call it PlantPAX. The Studio 5000 application can help reduce the engineering time to assemble your integrated architecture and process application. The Rockwell Automation Library of Process Objects is a collection of application templates, application code, graphic objects, faceplates, and process control strategies that let you quickly configure a device from an I/O to operator interface in just a few mouse clicks. Engineering your modern DCS has never been easier. Optional lab section, configuring control loop. Let's just do it because we are at 1 hour and 52 minutes, and I think we can get this done in 8 minutes, so we can pretty much be done with this whole lab in 2 hours, which I think is pretty good. So let's go back in here to Logix Designer. We're going to go to task B, right? and we're going to rename that to pressure control. In the section, we're going to import a routine. Add, import routine, PSPID, we're going to name it loop and find and replace X with P and 501 with 400. Ooh, man, I need my desk to be raised because I'm getting mad carpal tunnel. I'm standing right now, but my desk is just too low. Oof, that hurts. So we're gonna name it loop, and then we're gonna go to tags. We're gonna find and replace or name X with P. Place all. And we're going to rename 501 with 400. And then hit OK. We're going to import logic edits as pending. Okay. Then we're going to add import routine, the PVSD. We're going to name it drive. Do not hit OK. Replace 300 with 400. Then hit OK and import as pending. Double click on the drive routine in the pressure control program to open it. We're going to open up the block properties and turn on pset speed ref. I always sort the parameters. I don't know why you would not want them to have them sorted. Okay, pset. Where's pset? Pset speed ref. Apply. Okay. Then we're going to add a tag and we're going to call it the PIC 400 out CV. This is great. My keyboard's not working. PIC 400 underscore out underscore CB. Drop that into P set speed ref. Open up loop. View block properties. I'm just kind of blazing through this, guys, but I mean, it's video, so you guys can slow it down. But this is the optional section, and you know, I'm just going to show you guys how quickly it can actually be done. So we're going to open up this, and we're going to open up input CV initial value and input use CV initial value. Put CV use initial CV value, input CV initial value. Use CV, input CV initial value. Another thing is you can hit save instruction defaults, and then you can insert instruction defaults. So if you have something that you like, a configuration you like, open it up, hit insert, boom. Anyways, so now we got that there. So now we're going to add a tag and drop that into input CV initial value, and that's going to be MT400 value speed ref. So basically the initial value for the PID loop will be the current speed reference value when we're set to use it. So MT400 dot val speed ref. Drop this over here. Input CV initial value, and then we're going to only use that when the motor status is available. So when it's not available, we're going to use that CV initial value. And the not block, Boolean not. So this just drops it in with a name of B0.01. It's actually a little data type, but if you look in our parameter and local tag, it just throws it right there. So that's something to keep in mind. And we're just going to link this in here to here and here to here. And we're going to go back to the main routine and add a JSR to that, to the drive, and to the loop, and hit finalize. Now we're going to open a FactoryTalk View Studio and add component into application, the P1F process GFX. Local to C, lab files, FTSC. So under C, lab files, FactoryTalk View SC components, P1F process GFX. Open. So now we're going to go back to the P1F home button bar and add navigation to it. So we're going to scroll down, P1F home H button bar. Double click on screen 1. Action. Display. P1F process. Oh, no. Okay. Up appearance. Oh. Yep, so process screen. So we're just configuring this. Oh, stop that. What the heck? Gotta like click away. Sometimes the VM kind of gets screwed up. All right, hold on. Is it okay? Up appearance. Okay. Okay, hit save. Okay, now we're gonna go back to application, hit refresh, go to our process screen, and here we have our little thing. So now what does it want us to do? Navigate there, open up the drive. So this is the part that was not exactly the same. So we're going to open up this PVSD faceplate, and you notice that we're not able to see how this is grayed out. Well, on theirs they show you can enter it here, and they actually want us to enter in the max. Okay, so we're going to go do this maximum speed ref on engineering or maintenance, page 2, and we're going to say maximum is 60. Okay, it's already at that. Or no, we're going to put it to 100. 0 to 100. That's our speed ref. Now, what did I do to actually allow us to configure that? Okay, speed ref. Operator keeps control in program mode. Yep, now I can enter it in. Select the engineering tab and type percentage for the speed reference. And so this is also slightly different. So you can tell that there's been some updates since. Okay, so the feedback is in %, and this is the scaling as the output. That's the reference. Oh, the reference, they want it to be in % too. Okay. Click the PID object to launch the PID faceplate. Drag the PID faceplate to the right so you can see both faceplates. So here's our PID faceplate. Boom. Click the home and enter the speed reference. We will manually change the speed reference on the drive to see that this loop CV will track the reference value that we enter. Since the drive is currently not in program mode, from the PVSD faceplate, select the home tab, click speed reference input and type in a new value, and then hit OK. Notice the CV on the PID loop will track the value that you entered on the PVSD faceplate. That's the little binding that we did. So here we see CVs at 0. And it'll track whatever we manually set in here. 25, apply. Boom, okay? And so in order to open this up, that's that little trick that I had to use under engineering, or was it engineering? Yes, on page 4. Operator keeps control in program mode, or program keeps control in operator mode. So imagine if you have the pump in program mode, like, so programming is automatically starting and stopping that pump, but you want the operator to enter the set point for the speed reference. That would be program operator keeps control in program mode, and the opposite would be program keeps control in operator mode. So the operator starts and stops it, but the program controls the speed reference. And you can see we're in operator mode. So now we want to go place the loop in auto mode, and the VSD program mode to allow the controller to control the pressure. First, we need to configure the gains on the PID. Select the maintenance tab on the PID faceplate, and then sheet 3, and enter 1 for proportional and 0.5 for integral gain. Where is this? Engineering page 3, or maintenance page 3. So proportional will go 1. Integral, we will go 0.5. Okay. Select the engineering tab of the PID faceplate, then select sheet 2. Uncheck the box to force the loop to manual mode when the init request is present. This will allow us to place the loop in auto mode, even if the VSD is not in program mode. Engineering, page 2. Go to manual loop mode. Oh, we got to uncheck that. Boom. Okay, that's what I was probably doing wrong before. Return to home and place it in auto. Yes. See, you just got to read the instructions carefully. The PID-CV output is still initializing and tracking the output of the VSD since the VSD is not in program mode. On the VSD faceplate, select the engineering tab and then sheet 2, then click mode configuration button. So let's read that again. The PID-CV output is still initializing and tracking the output of the VSD since the VSD is not in program mode. So let's look actually at this code right here and see what that is actually talking about. So under, what is it, loop? Here. So the value speed ref is 25, and because the status is not available, meaning it's in operator mode, it's going to say use the CV. So that's why it's still tracking at 25. But if we go back into, even though this PID is in auto mode, it's not tracking because the pump is not tracking. But if we go here, we can go to engineering, or no, maintenance, page, no, engineering, page 2, engineering, page 2, mode configuration. This is where we select the default mode. So right now the default mode is operator. Now there's program bits that you can use to request program mode, and then the program could release it back into operator mode. But I actually think what makes more sense is having the default mode be program, and you'll see why in a second here. So on the home page right here, you see how it's an operator, and all I have is the ability to lock it in operator mode or to unlock it. I can't force it to go into program mode, only the program can. But if the default is program, then you'll see we're in operator mode, and the default behavior is that it'll show the logo when it's not in the default mode. So, and when we release it back into program mode, you'll see it goes away. Now you can change the icons so they both show up no matter what, and now you can see we can just boom, click it back into operator mode. It tells you it's in operator mode. I think this actually makes more sense. Typically you want things to run automatically, and if it's in operator mode, it's probably like a rare scenario or something like that. So now if we put it back into program mode, this should track. Let's see. So, yep. Put it into program, hit OK, go request program mode. That's what we did. The PID loop will no longer be in CV initialize mode. So we could see in this, it's in CV initialize mode, and here it's not. Enter pressure set point from the PID faceplate. Say 50 psi. So now it's hunting. The loop CV will increase or decrease accordingly to and update the speed reference set point on the drive. You have successfully configured a pressure loop control loop to regulate the speed of a drive. Congratulations, we're done with the program, and we finished in 2 hours and 12 minutes. Cool. All right, guys. So I hope you guys liked that. I don't know, I had a lot of fun doing this. Like I said, I'd done this one time before. It probably took me 3 or 4 hours the first time. I kind of missed that section where I had to uncheck that box. I thought it said check it. And then, so I'm like, oh, it's already checked. And then that auto button was grayed out. You know, obviously having this, this manual like makes it really easy to kind of go through really quickly. And when you're developing it for your specific needs, you're gonna stumble. You're gonna not be able to figure something out for the first time. The documentation on these objects is just amazing. So definitely check out the documentation. Each object, each PAIN, PVSD, P motor, P valve, all have like their own documentation set, explains every single parameter and pin, what it does, what the default behavior is, the faceplates, everything. So, and then if that fails, Rockwell Tech Support has a option for PlantPAx support, or just reach out to me. Leave me a comment in the YouTube comments. Send me an email at zachscriven at gmail.com. Yeah, I hope you guys liked it. Get subscribed. Catch me in the next video. Drop me a message for suggestions for future videos. Thank you again to Rockwell for supporting this cause and letting me make this video. I hope that it's valuable, and hopefully I'll get a chance to edit it into a more condensed format. But at 2 hours and 15 minutes, I don't feel like that's too long to watch, and maybe you can watch this while you're doing it and pause and play. And if you guys get stuck, you guys can see exactly what I did from start to finish. So I'm not really hiding anything. Admittedly, I did go a little bit faster, during that loop section, but I was just trying to wrap it up. It's getting kind of late here. I don't even know what time it is. It's 1:52. So, obviously you guys could tell I love this. Otherwise I wouldn't be doing this. So, if you guys found value, like I said, make sure to hit like, get subscribed, turn on notifications, and I'll catch you guys in the next video. Peace.